You are listening to Deep Neural Notebooks, a podcast where I like to discuss a multitude of topics ranging from deep learning and computer vision to neuroscience and open source software through conversations with experts about their thoughts on the state of their specializations, how things fit into the bigger picture, their journey so far, and the road ahead. If you like the content, please subscribe to the channel and leave a thumbs up or a star rating depending on the streaming platform. Thank you. For the first episode, I'm delighted to have Professor Shanmuganathan Raman. Shanmuga sir is an Associate Professor of Electrical Engineering and Computer Science at IIT Gandhinagar. He has been my mentor for my research internship at IIT. He has obtained his MTech and PhD degrees from IIT Bombay and was a postdoc research associate at Department of Electrical Engineering at IISc Bangalore. His PhD thesis on low dynamic range solution to HDR imaging problem received the IIT Bombay Excellence in PhD Thesis Work Award. His research interests include computer vision, computational photography, machine learning, and computer graphics. In this episode, we discuss his educational background, his thesis, the state of HDR imaging, and computational photography. We also talk about deep learning, the scope of traditional algorithms in a DL-minded society, and the road ahead. Hello sir, thank you for talking to me. So I wanted to add some questions about your experience. So you have had an interesting educational background. So you started with electronics and communication for your BTech and then you moved to biomedical. So that's sort of an unorthodox switch. So could you talk about that?
Yeah, so I did my undergraduate electronics and communication at PhD College of Technology in Coimbatore. And during that time I was more of academically good student, but probably I was interested more in securing grades and everything. I never thought of taking research as a passion that much during my BTech. Yeah, so I got placed in the campus. I never thought about higher studies. I joined a company.
TCS you joined?
Yeah, TCS. Right. So then I worked on multiple projects in that company, and then I found my heart was not right there, and so I wanted to explore. So then I gave GATE while working in TCS, so I could secure a good rank, and my rank was good enough for let's say biomedical in MTech, to be honest, but in IIT Bombay, institution like IIT Bombay, but not I should have opted for some RA, which is a 3-year MTech program and other things, because my rank was not up to the mark to get a 2-year MTech in electrical engineering. So I had to settle down on a branch which I like electrical engineering, or explore biomedical engineering by opting in a top institution like IIT Bombay. I opted for the later, so I joined IIT Bombay and tried to explore.
So IIT Bombay was kind of the preference.
Yeah. So, but the reason behind biomedical engineering, because after my 12th also I got a medical admit, but I didn't join because I wanted to pursue my passion as engineer. So I had a biology stream till 12th, and the 4 years there was a gap. And and during the after the GATE also there was a written test in biology at IIT Bombay, so which I had to clear to face the interview. So I had to again prepare. So, but that background when I was in 12th helped with biology.
Okay. So that's why the transition was not that difficult, because other people would have been coming from a medical background.
Yeah. So my class comprises of 2 types of people. One from the engineering stream, they had to give a biology test and face the interview after GATE. And those who are MBBS doctors, they had to give engineering and math test and then face the interview. So my class had some MBBS doctors also.
Okay.
So it was a right mix, and it was a optimal size, around I think 14-15 students, and we had a good time.
Right, but was it difficult initially? Because biomedical, is it like computers and sort of...
Yeah, so there are some courses which I found very easy. For an example, there was a signals and systems course, which was like kind of a walk easy for me. But there were some courses like biomaterials, for an example, and some biosensors, and those kind of courses I had never done actually. So the normal electronic instrumentation I had done during my UG, but biosensors kind of thing, the approach was very different, right? How to the sensor design and the transducer design was entirely different. So I had to put up a lot of effort, and some courses I had to prioritize also. When I entered IIT Bombay, the first semester I had, I think 8 courses, 3 half semester courses, 3 half semester courses, 6 courses, and 2 courses which run through the entire semester. So it was quite like kind of how to balance. So some of the courses I could score well, I could like kind of concentrate more, and some of the other courses I had to just scrape through. So then I settled down actually after the first semester.
Right. So would you sort of recommend this approach of exploring other opportunities before you sort of settle down for one?
Yeah, that is okay when you do a master's, but not for a PhD, because that would decide your future career also. So like kind of I had the MTech was like kind of an experimental phase where I could like kind of explore. I had always been fascinated by some of the biological components, especially the neurons and other things. So I wanted to learn. So I used to, like, my supervisor was Professor Rohit Manchand at IIT Bombay, and he gave me a lot of freedom to read a lot of papers in nature, science, and everything. So I would have read a lot of papers, like kind of that helped me to like kind of connect myself with the pure science.
Right. So, but how was like research back then? Because we didn't have archive and all those things.
Yeah. Most of the times the journals were subscribed like kind of by the library, and we had to go to the Nature or Science website and download those articles and read. There are two journals which I like the most: the Nature Neuroscience and Nature Neuroscience Reviews, which was giving an excellent overview of the field. Actually. So those things were subscribed, and if not subscribed, we had. If you request the librarian, they could arrange to get some of the articles. So that was quite useful.
So how much of your work at IIT Bombay during your MTech was about neuroscience? And
so the coursework was common, like first year coursework was like kind of common, and there was some kind of elective courses which I did mostly on signal processing, wavelets, and image processing, computer vision, those kind of courses. And the research was entirely on neuroscience.
So about your MTech thesis, computational investigation of synaptic integration.
So I started off with like exploring topics in the areas of related to some signaling. So in the neural signaling was one of the hard problems at that time. Especially there is a region in the brain called hippocampus. It has something called CA1, which contains some pyramidal neurons, which was found to be responsible for learning and memory.
Okay.
So there is something called long-term potentiation which translates into memory. So that long-term potentiation gets initiated in this hippocampus region, and then the memory gets stored in the cortex and other regions.
Okay.
So I tried investigating on the neurons, especially in this region, and what we did was we didn't do the physical neuron studies, but we adopted the reconstructed architectures of neurons in the brain. By some groups using softwares like Neuron and Genesis, and then conducted experiments. Simulation.
Right. Okay, so
and we tried to study how different synaptic inputs for a given neuron will be able to are getting integrated. So it was a single neuron study only.
Okay.
At a single neuron level, how different inputs at different parts of its dendrites get integrated in the cell body, and then.
Right, so we have one neuron and it has multiple synapses. So how one neuron receives the input from multiple neurons?
Synapses, and there are like kind of proximal synapses and distal synapses. So there are synapses which are close to the cell body, and there are synapses which are far away from the cell body.
Okay.
How all of them get heard by the cell body and gets integrated and seen if there is it crosses a threshold to fire an action potential, which then carries forward to the next neuron.
Right, so the computation that happens in sort of integrating all the synaptic inputs.
Yeah.
So relate some you speaking something about synaptic normalization. So could you?
So synaptic normalization is like kind of how that it is a study on how the distal synapses get heard actually.
Okay.
So is there some chemical or electrical phenomena which aids in transmitting the synapses which are far away from the cell body still getting integrated during the synaptic integration process.
Is this normalization similar to the activation functions that we have in neural networks?
Not really. The activation function is a prescribed function. This normalization happens through some ion channels and other things. So that's slightly different. When I was doing this study, I never had tried to understand how neural networks and how the actual neurons. So my job was to just investigate from the pure scientific viewpoint, uncover the physical phenomena which leads to something called the synaptic integration.
Right. So is this sort of computation analog or digital or both?
So the synaptic integration process is analog, but after the action potential, whether it is fired or not, it is a digital process. If it crosses some threshold, then action potential will be fired.
So is this because of the chemicals that are released inside a neuron
the action potential is due to some kind of the chemical ions transfer and other things, but there is we can computationally study it also using something called Hodgkin-Huxley model. They characterized using some equations. And well, if the action potential is fired, you study it computationally also. We need not go into the ionic mechanisms to study that.
Right. So, what sort of insights can we take from this to understand about the learning process inside the brain?
So this is like kind of it's very primitive level. This is at only one neuron level. So to understand the actual process, you need to see how neurons as a collection of bunch of neurons interact, and then how they work together to create that process. But it is a very fundamental study which we targeted on studying how at a single neuron level this happens actually.
So all your observations during your thesis, and your knowledge about how a neuron in a neural network works. So how similar? They're very less similar, but what sort of comparisons can we?
So comparisons, there are something called like kind of some kind of what do you say? The weights are there given to different things. So similar weights like kind of that the proximal distal synapses I was talking about. So something may be boosted through ionic mechanism so that it gets heard in the cell body before the integration process. So that could be analogous to a neural network, but neural network is a much simplified structure compared to the actual neuron. At a single neuron level itself, only a single neuron does have so many synapses. I mean, lot of synapses, and the connections are very complex, and the process itself is very complex. But maybe the connections are there everywhere, right? So it is like kind of you may say that this neural networks got inspired by social networks also. It can get inspired by molecular networks also. But because the name is the same, the neural, right? So then there are more people, but the actual main paper that McCullough, which derived some ideas from the neural network, the actual neuronal network in the human brain to model the initial neural network. After that, both the fields are diversified. The tasks are also different.
Right. So, what do you feel? I mean, the future of sort of learning mechanisms inside through algorithms and inside robots. So, do neural networks? I mean, would they still fit in the picture, or would they be replaced by some completely different sort of mathematical architecture?
No, neural networks are here to stay now, right? Because like kind of the computational tools which people have developed, and people are not looking anything beyond this neural network, except possibly, I may be wrong, some few groups in the world. So everyone is like now going with the tide, right? So they want to use neural networks to solve all the computational problems, and multiple different architectures are being produced, and multiple different ways to learn. There is supervised learning, unsupervised learning. There is something called self-supervised learning. There is reinforcement learning, and many new schematics are centered only around the neural networks only. But next to 10-15 years, it is going to stay like neural networks as it is now. So, but unless there is a huge breakthrough which can displace neural networks, I am not seeing it any time in future.
So let's talk about your PhD at IIT Bombay in electricals and computers. So before that, so what sort of helped you switch back?
So there were two options before me after my MTech. One is to go into the experimental neuroscience, which I was not very comfortable with, because like kind of you have to maintain a lot of species, and you have to like kind of dissect them and other things. I have never done that. So because I had to investigate some new phenomena, that was the one way to go. Like kind of computational things I had learned quite a bit during my MTech, but I wanted to take one step further, but I was not comfortable. Then I had done some relevant courses during my MTech, signal processing, computer vision, and like kind of that time the machine learning was not like kind of that prevalent in tasks for computer vision. There were some people who were doing, but I was fascinated by those kind of courses, and I wanted to explore more. So I opted for a PhD in electrical engineering.
Right. So you did your thesis was around high dynamic range images. So when was it that you first heard about this, and I mean, why did you feel you wanted to go with this sort of thing?
So I had like kind of done some courses with my supervisor, Professor Subhashish Chaudhary, and we had some initial discussion on that. So we had to again do a thesis seminar before like jumping into the thesis work. So during the seminar he gave this problem, like kind of there are people who do take multiple exposures, combine them, and everything, you explore more. Then I read a lot of works, especially the pioneering works by Mann and Picard, which was in 1995. that introduced the area of HDR based on so there is something called Wyckoff principle and other things. And then I read the paper by Debovec and Malik in SIGGRAPH 97, and then I thought of exploring more on that. Then we started working together.
Right. So your thesis, it got the Excellence Award at IIT Bombay. So
yeah. So
could you talk about your thesis?
Yeah, the thesis, especially we had to. The thesis theme is very simple actually. So the earlier people were doing HDR imaging by generating the HDR image from set of multi-exposure images, combining them, and then again doing the tone mapping operations. So we wanted to relieve users about the this full process actually. Okay. Directly can we, given a set of multi-exposure images, can we generate something like a tone mapped HDR image directly?
Right.
So that was the fundamental idea.
So was it manual before, merging the multiple images?
It was not manual, but merging the multiple images, you will get the HDR image. But the HDR image, there was no display which could display them. So again, you have to do a tone mapping operation.
Right.
So, and for generating the HDR image, you had to know the camera response function and other things. So we didn't want to get into all those things.
Right.
We don't know anything about the camera. Given a set of multi-exposure images, can we directly get to a tone mapped HDR image?
Okay.
Which can be displayed on all devices and which retains details both in the brightly and poorly lit regions of the scene actually.
Right. So a tone mapped image would be a low dynamic range image, but a better version.
Better version. So it is like you can say a high contrast image which has details both in the bright and poorly lit regions.
Right. So that was your thesis, low dynamic range solutions
to the high dynamic range.
High dynamic range image. Right. So computational photography and HDR imaging is sort of getting quite a lot of traction now. These HDR video formats are coming up. Google and Apple are sort of trying to get the best cameras with the best sort of software for this. So what's your take on the field right now?
Actually the research on HDR was bit of on the not so much till the deep learning era started again. So I completed my thesis around 2010-11 times. Also there were not many publications on HDR in the top conferences, only few. But later on, with the deep learning and the GANs chipping in, so there were you can also synthesize new images through deep networks. So that confidence people got.
Right.
There were some initial works, and then now if you see all those works which are generating the HDR from a single LDR also, all of them are deep learning based. So people have started doing that. Then the companies also, the mobile cameras also, were just used to capture images, and they didn't have that much processing power to synthesize or generate better versions of the same image.
Right.
And now people have so with the evolution of the mobile sensors and the mobile processors, which are very powerful, people have started taking multi-exposures with a single click and then combining on the fly to generate a sort of HDR image. Even those images which are HDR, the Google Pixel and the Apple Smart HDR for an example, I think they are tone mapped HDR images only because the final images are displayed on your cell phone devices.
Right. So, but are they using sort of classical algorithms with sort of flow for motion approximation and things like that, or are they using sort of deep learning based?
I think it is mostly deep learning based because they train the model at their end and then the trained model they use it in the cloud or on the mobile devices to on the fly generate HDR content actually.
So what's the problem with the classical sort of approaches other than the fact that sort of motion approximation is not that
accurate? Classical approaches, if there is a region which is oversaturated or undersaturated, it tries to fill it from only those set of images actually.
Okay.
But the deep learning approaches, it learns through multiple underexposed images how they have been filled.
Right. It can hallucinate.
So it can hallucinate and bring in details which are not present in those set of few multi-exposure images only.
Right.
So that has enabled these kind of manufacturers to go to the with the confidence to the consumers saying that any kind of overexposure, underexposure we can take care using our HDR solutions.
Right, and that's probably something that they have in the low light sort of images also.
Yeah.
So I believe that the cameras today, they have sort of exceeded the human visual system. I mean, they're far better now. So does
not
the point
really, but because the sensors as such, if you see the dynamic range of the sensor element itself, it's not that high.
5 stops for a normal camera and I think
5
12 stops.
And if you measure in dB for an example, it's 80, 90 dB for an example. Human vision has some 140, 130, 140 dB, so which is quite high.
Right.
Like kind of so we have not reached it, but due to this
with the software
with enabled with algorithms enabling at the back end, we are trying to mimic the human vision actually.
Right. So how far does this go? I mean, does the point come where we have we have everything, because we have low light, we have autofocus, we have telephoto.
So what we envisage from the beginning also, the HDR image, when we create like a HDR image, so it enables all other applications like kind of a visual tracking or any object detection and everything, right? So the data itself is very clean, like a HDR image, which is details both in brightly and poorly lit regions, which has very high contrast. So that enables all the other algorithms to function better actually. So now people would start capturing with the HDR mode enabled in their cameras, whether it is Pixel or iPhones and other cameras, and the performance of the other algorithms also will.
Right. For example, for robots doing image classification or something like that. So the better the image, the better the classification.
Yeah. So the more datasets will come with more cleaner images, and because most of the consumers also will take cleaner images due to these methods actually. So that would enable, but even now the datasets have not so clean image, because still the people are not using the HDR mode. Most of the people use like
most people don't know what is
HDR mode, and
even I thought it was high definition or something.
High definition, so they don't know the difference between the range resolution and the spatial resolution. So spatial resolution we have achieved like very good, like even 16 megapixel, 12 megapixel you get in your common cell phones also. But the range resolution now
so this range is it because of the memory of the sensor, of how much sort of the range it can accommodate?
It is due to the sensor element. Each sensor element, what is the well capacity of each of the sensor.
So is that also likely to improve?
It is getting improved. Like kind of, I have been following those literature from the microelectronics groups. Like so, they are trying to use something like organic CMOS to improve the well capacity. But still, they are at the research end, and they have not been like commercialized. The Panasonic was trying to do something, but I don't know about the other companies, whether they are working at the sensor level itself to improve the range resolution.
Or improving on the software.
On the software, The software is the easy way forward, because they like kind of, unless it is like benchmarked properly, the sensor we can use with any traditional sensor which is low cost, and then augment it with the software.
Right. Fine. So you're an associate professor at IIT Gandhinagar. So what are some of the projects that you're working on?
So the HDR we are like kind of trying to work on a new algorithms which would try to create HDR video content, which you may also be aware of, right? So we try to enable the commercial cameras itself to generate HDR content. So which has not been commercialized as yet. Only the images are in the HDR mode. Now we want to like take it to the HDR video. So that is the one thing we are looking for. And there are some groups which have already done, they demonstrated that it is possible to generate HDR video content using commercial cameras with either with normal exposure, only single exposure or multiple exposures. So there are some works in recent past which have been published in Eurographics and SIGGRAPH and other places.
Right. So, and some other projects, I think you're working on 3D related.
Yeah. So one more project we are getting into is geometry processing. Like kind of, we want to build a entire pipeline from the scanning to restoration to printing, for an example, especially for some kind of rare artifacts which can be destroyed due to human negligence or due to natural calamities, like some ancient artifacts, right? So we want to preserve them by scanning them, and then if they are already damaged, we want to fix them using the 3D processing or geometry processing tools, which is also now deep learning based. Like kind of most of the 3D deep learning is used to do that, right? So we want to do that, and then kind of
so setting up the whole pipeline from scanning the artifact, and then
so the vision is to have a website in IIT Gandhinagar where we can host all the artifacts which we have digitized. And then the printing may offer it as a service, like kind of if someone wants to host the digitized artifacts, we may print here and supply them.
Okay. So what would be the scale of these artifacts? Would there be miniature models?
Yeah, it depends on our scanning device. So our scanning device, like when it is operating on a turntable with the scanner mounted on a tripod, I think it would be like a water bottle size kind of thing. Right. So that's the size of the artifacts we do. But we have another work which we are doing is to scan large structures, large structures, which is monuments and other things, and digitize them, which can be used for tourism, for providing visual walkthroughs or like kind of.
I think IIT Gandhinagar's website has a visual walkthrough. So
Visual walkthrough, yeah.
Right.
That is a different one, but that is
Okay.
like mostly a rendered walkthrough. So that was through some maybe photo stitching and some kind of rendering they have done. But what we want to do it is for the tourism purpose as well as this one for gaming development. So they want to set up a monument as a gaming domain, and they want to design it. So we'll give the environment through that.
Is this a government project?
It's a Serb imprint too. So which our industrial partner is NVIDIA, and we try to do it.
Right, cool. So now let's talk about deep learning a little bit. You have sort of seen it grow from 2012, then models getting deeper. So how has your view about it changed since the beginning?
No, I was never a kind of enthusiast of deep learning till let's say 2015.
Right.
So I was doing classical computer vision only. Most of the problems I have worked on with even my first two PhD students never worked on deep learning algorithms. But because some of the challenges there were some kind of a theoretical limits on some of the performances of some of the tasks, right? So on the performance of some of the tasks which have been broken by deep learning based models, because earlier I was not very happy with the idea that you need to train so many models, but there have been some approaches like unsupervised learning and other things which are relieving us from training on. There are something called learning free methods on tasks like there is a deep image pair which was a paper last in CVPR 2018, so which they have demonstrated with, and the best paper award won in CVPR 2019 SynGAN. So they say that with a single image itself you can learn things. So those kind of things motivate us because they motivate even the researchers who don't have so much resources to buy so many GPUs to train the models to still do deep learning research.
Right. I think deep image pair was sort of in a way improving the quality of the image. So the network sort of learns how to. It doesn't learn. Network is able to sort of suppress the noise that's there.
Yeah, it is a filter only. The network itself functions as a filter to to do denoising and to fill some missing parts and to do super resolution everything. Right. So traditionally we used to have a bilateral filter or a non-local means filter to the denoising. Now a deep network accesses that actually. So that was the finding they had. They call it a learning free approach. Right. And we are also one of my PhD students with us. We had a CVPR workshop paper this year, which studied more in depth such a paradigm.
Okay, cool.
So
Right. So Jeremy Howard, he said this in one of the podcasts of the artificial intelligence podcast. He said that most deep learning research is a waste of time. So what's your thought on that?
Yeah. So deep learning research as such, most of the things which are published in say NIPS, CVPR, ICCV, ICML and ECCV, so those SIGGRAPH, Eurographics, those things are quite useful actually. So it is what kind of deep learning he's talking about, I don't know, but I refer to these venues, the papers, and they have been giving more insights into some of the problems which I had no insight into. I could, with every paper I could build a knowledge base actually. So I think if someone is doing the research at the level of these kind of venues, so then those kind of research is always useful actually.
Right. So let's say there are some sort of applications being tried out in the world wherein the applications are not that useful. So do you think experiments performed for those applications, do they sort of contribute to the global knowledge? Because deep learning is mostly experiment based. So probably something that worked there might help other networks.
Yeah. So my take is on this only. Some people directly start with deep learning as the only tool to solve a problem. So one should go with an open mind actually. Right. So and those who are entering deep learning also should have strong hold of the fundamental concepts of computer vision, let's say geometry or signal processing perspective. What are the feature extraction modules and everything?
Yeah, probably that will help.
That will help actually. So those kind of things, if they had done, so most of the work could be given more meaning actually. And even the people are trying to reason out why the deep learning networks are working. For an example, there was some couple of papers in ICLR I read last year and this year. they have told what the CNN does is analogous to what a Gaussian process, random process does. So they're trying to like kind of analogize or like kind of try
Get
to
into the black box that
what
it's
it
called.
does. So those kind of works are give us something. Even the works which are not given meaning by the authors themselves can be given meaning through by connecting them to some works like this actually.
You're mixing the classical algorithms with the sort
With
of
the art like kind of how benchmark it like kind of a traditional like kind of a statistical learning with the deep learning approach and can be like kind of get some connection between them. So then we can draw meaning to most of the deep learning research if we are like kind of but the onus is on the reader to connect it to the appropriate work which describes it. The authors themselves may not describe it.
Right. So, what directions do you think that deep learning and computer vision would take in the future, or what direction it should take?
Another 10 years it would go hand in hand like kind of if you see most of the publications in the top venues are deep learning based and there have been a lot of new things like evolved over the past years and the GANs are here to stay and the kind of other algorithms like RCNN and other things for the region segmentation and those things are here to stay and even like kind of most of the tasks like even I read a recent paper on KSVD, which was a classical algorithm for denoising. So they are trying to reason out by giving meaning through deep learning. They have released a paper called Deep KSVD denoising. So most of the classical things, like they are trying to build a network which could mimic the classical things. And over that, if we modify the network, then it will perform better than classical thing. So most of the classical things, there will be analog of a deep learning based network which will do the job. And for the next 10 years, I think we would have enough problems to like kind of get into to introduce the problem into the world of deep learning.
With even the computation sort of getting higher and
getting higher, but there have been works which say that you don't have to. But
Right.
there have been like kind of but the problem is like kind of the community being stuck with some data sets. For an example, like for the action recognition task, for an example, there have been some data sets which you require some humongous amount of computation. Then only you can enter into that kind of research. So those things the community has to rethink, like kind of to enable everyone to like
get into it and contribute something.
Yeah.
Right. So do you think smaller but well-crafted data sets would help?
Will help definitely, and the most of the benchmarking should be on data sets which can be done by research groups having sufficient amount of computation. It should not like kind of require you to like kind of establish the entire computation strategy before even entering into that. So those kind of things the community has to take a call, like where how to enable more researchers having like kind of limited resource or like kind of the basic resources to enter into deep learning research. But the researchers like research works like this SynGAN and the other that deep image prior.
They're
enabling those kind of things. So even those researchers can go in that way and then do computations with the limited resources and still publish good quality works.
Right. So let's talk about the more traditional and the classical algorithms and the approaches in computer vision. So with deep learning taking over almost everything, so how do you see these more traditional approaches being there?
Yeah, there have been some works in the recent past, especially in geometry and some computational cameras which do not use deep learning. So new camera architectures have been being designed, and even some of the geometry problems have been solved. For example, even in our group, my first PhD student Rajendra could solve some of the problems in symmetry without using deep learning. But having said that, because most of the top conferences like ICCB, CVPR, ECCB, SIGGRAPH, Eurographics, and everything, 80% of the papers use some kind of a deep learning or the learning based algorithms, right? So the scope is very limited, but still I feel like kind of if there is a persistent researcher who thinks that he can explore and find out appropriate problem which he can solve in the classical means, there is room for him or her to like kind of publish in a top place. But because of the advent of deep learning, the challenge is to like kind of solve a very important problem which the community thinks relevant in the classical sense. So then there is a scope. But the times have gone of those algorithms which are like kind of a traditional kind of thing, which the deep learning has already provided much better solutions. Then it is highly unlikely that such works will be accepted in a best computer vision venues.
So deep learning has become like more and more ubiquitous, and like anyone can just come in, have a good data set, and put in a basic neural network, and then get decent results, and then work on that without sort of expertise knowledge in the specific subject. So does that overall, is that a little bit unfair for the people who are sort of working full time on the traditional algorithms and trying to solve the things mathematically? Or
So there are two ways to look at it. The positive thing is like more and more people get interested in AI based research domains like computer vision, NLP, and social networks and everything, because everyone wants to do deep learning, which is easier to get in. Previously there was a lot of background required for people to enter into these domains to start research. So now the starting criteria is very less, but where they end up over a period of time depends on how well they equip with the existing techniques, also like kind of how much background idea they have about the problem as such, irrespective of what platform they use. And therefore I say to my students, like kind of whether you want to do deep learning technique also, but you should be good in the classical vision things also. Otherwise, having only the deep learning as a tool is not sufficient. You need to have good problems to solve using deep learning. That will identify you and kind of make you different from other researchers who are just using deep learning to solve traditional problems.
Right, and we can also see that the expertise knowledge can also, you can use that to sort of optimize your network, optimize the loss functions, and
there may be problems where deep learning may not be necessary also. There may be, you can solve it in the traditional sense also, which may be a landmark work also. So those opportunities you will miss out when you just make up your mind that I am going to do only deep learning.
Right. So now let's talk about the state of research in our country. So we're number 2 in population, but we're lagging behind China and America. So despite the number of efforts being put in by government organizations like IIT, where do you think we are lacking, and how we can?
The situation has drastically improved over the lot of years, and because of this deep learning, thanks to deep learning, many of the Indian institutes are now getting papers in top places like ICCV, CVP, RECCV, because like kind of there have been like kind of it has opened up, it has like kind of liberalized the area of computer vision research. That's what I would say, this deep learning. So there have been important problems solved by Indian research, but as you mentioned, like kind of considering the population we have, like we need to do more actually. So we need to, like, even some of the conferences have helped also in India. There is ICVGAP and NCVPribG, and both are like kind of double blind, by promoting research, and their double blind reviews, and very selective papers get accepted and everything. And there have been important national level projects undertaken by the computer vision researchers which has helped. But what I would like to see is like more students who are now doing computer vision research in India take one step further and publish in the top venues. So as one generation of students start publishing in the top venues and important problems they solve, then more awareness will be created, more students will be motivated to like kind of scale heights. So that thing we are in the process, but at present it is not like, we cannot say, like, even if you see the statistics of CVPR, ICCV 2019 for an example, most even Chinese papers are more than US papers, right? So kind of we are not even close, right? So that trend should change, because like most of the that's another thing. There are schemes from government also, like a Prime Minister Research Fellowship, and that I heard like IIT Delhi has allowed students to directly take a PhD after BTech in NIT. So those things are means to like kind of give them a head start, like kind of they can start at the age of 21, 22 and invest next 5 to 6 years solving some core research problems, target top conferences. So that opportunities and some of the landmark decisions which have been taken in the few years have helped to aid the scenario of research in India. But we need to wait and see how the outcome would be in the next few years.
So, in your opinion about So IITs are doing quite well in terms of the number of publications. So what do you think that they are doing better than the other? So even the private universities, which are likely to perform better because they have more funding and that way. But what is sort of IIT doing better there?
And actually, the IITs, like the primary focus of IITs, the one is undergraduate teaching and the high quality research. Both of them have been the main this thing. So if other institutes have to just follow the like kind of scheme adopted by IITs, which have projected them to this level. Already, triple IITs are doing exceptionally well. Some of the triple IITs and some of the NITs also are doing reasonably okay, but
Right.
they have to like kind of just take these institutes as role model and follow the best practices these institutes adopted, so that they can also catch up or even enter into the race with good publications in the top venues.
Right. So let's talk about the overwhelming amount of research that's going on in the world. So how do you stay updated with the trend, with the research trends, basically?
Resistance, it's simple. Like most of the times, I read up like kind of the papers in the top conferences in ICCV, CVPR, ECCV, and SIGGRAPH, Eurographics, ICLR, ICML, NIPS. So these are the places I look at every time some paper acceptance list comes. So I go through certain keywords which I would be interested, search those papers and just read the abstract whether the paper is interesting for me or not. Then go in depth. Another thing which has helped me a lot is the tutorials held as part of these conferences. So they condense information and it's the effect of this tutorial is like having read some 50 papers, like because they summarize everything and give it in a good contextual,
even with the background of
with the
how the
background and
field
everything.
where it is going and things like
So whether you want to get into the area, it's better to follow the tutorials. Now the CVF videos are up on the YouTube also. So most of the conference tutorials are available on YouTube, so which we can directly access and process, right? So that way also it helps.
Right. And for your students, so I mean, what sort of tips do you give them to, do better in research as an individual?
Yeah, set high limits, like try to follow researchers who are doing exceptionally well in those sub areas of computer vision. Follow their research and what has distinguished them from others, and set themselves a role model and try to reach that height. And don't restrict yourself to some established practices. Always think of some novel ways to solve a problem, or like I give sufficient freedom to my students unless there is a dying need. I don't step into guide them, when the problem formulation and the initial conceptualization we are together, but the student won't, because otherwise it would be like traditional ways of solving we again get into. So that way some of the students who have joined my group, first 2-3 years they spend a lot of time with both of us discuss and everything, and by the time in the PhD in the 4th or 5th year they become reasonably independent to form their own problems and become independent, and that way the novelty of the work also tend to increase towards the end of their programs actually. And most of the time I encourage them and share in the groups a lot of recent developments and other important papers and videos which have come up. And so we officially don't have group meeting and other things where we discuss, but students walk in my office anytime and we discuss whenever they are in need. So that model I like, because otherwise the group meetings I tend to feel that some may be doing well, some may not do well, that there would be some discrepancy among the students also that comes out, and that should not bog down some of the students who can catch up at a later time, but not in a good sense. Because in research, sometimes results some students may get, some students may get a lot of acceptance and they may be doing well. So it is about giving importance to each and every student. So and assessing their capabilities and give them problems which they can attempt and solve in a limited period of time.
Right. So, sir, you're an avid reader. In one of your classes, you were mentioning how you like popular science books, and so what sort of books are you reading now? And could you point out 3 top books of yours?
So I like books by Bill Bryson, for an example. There is a short history of nearly everything that I like, and Simon Singh, for an example. Fermat's Last Theorem. There is a code book he has written, and Big Bang. Many books I like about him also. And there is Carl Sagan, his books also I like, Cosmos and many other books. So presently I am reading a book called The Culture Code. it is a very good book on like kind of how to build a successful group, what are the how to manage a group, and there have been very good case studies and how to like kind of get high productivity from a group and everything. So that is the one book I am reading.
Right, thank you so much. And so before we sort of close this, I know you like cricket, you follow cricket a lot. So I had 3 or 4 questions that are sort of quite important at this point of time. So you prefer T20 or Test cricket?
Test cricket.
Nice. Virat Kohli or Sachin Tendulkar?
Virat Kohli.
Virat Kohli or MS Dhoni?
I must do.
And Chennai Super Kings or Mumbai Indians?
I don't care.
ठीक है. So it's nice talking to you. Thank you so much, sir. Thanks a lot. Thank you.